Alright, today we are going to have section 3.4, and the objective is solve equations with variables on both sides. Solve equations with variables on both sides. And that means both sides of your equation. But first let's talk about what a linear equation is. A linear equation is going to be an equation with x and y in separate terms and both x and y to the first power. So you have an equation with x and y in separate terms and to the first power. That means x and y need to be to the first power. So you have two parts to this definition. Well, it's an equation for one. And then it's going to have x and y in separate terms and x and y to the first power. So let me give you three examples and you tell which one would be linear. So the first one, 3x squared plus 2 equals y. Second one, 5x minus 8y equals 1. And third one, 4 times x times y equals 10. Alright, so according to the definition, you want an equation, and all three of them are equations. Second part of your definition, you want the x and y in separate terms. So separate terms means they're separated by addition or subtraction signs. So that works for the first one, it works for the second one, but it does not work for the third one because this is considered one term. There is no addition or subtraction sign between the x and the y. So this one would not be linear. Then we'll go to the third part of your definition. The criteria is that x and y should be to the first power. So in the first equation, x is squared. So because x is squared, this equation will not be linear. So equation number 2 satisfies all three parts of the definition. It is an equation. X and y are in separate terms. They're separated by this minus sign. And x and y are to the first power because this is understood to be the first power and this is understood to be the first power. If there's no power given, it's understood to be to the first power. So equation number 2 is linear, which means it'll graph into a line. We'll talk more about the graphing of it in a different chapter. But right now we're going to go on to these linear equations. So let me scroll this down. And you have three equations. Here we go. Three equations, and in each equation you have an x on each side, or in the third equation you have a k on each side. So your job is to get that x alone. So first of all, you want to get the x on the same side. So in equation number 1, you have an x on both sides. Now if I think about it, I could move the x to the right, or I could move the x to the left. I choose to move it to the left because I would like to make my coefficient on my x positive. But if you don't mind it being negative, it doesn't matter which way you go. So I'm going to add a 2x to each side of the equal sign, which means that on the left side I'm going to have a 9x plus 19. On the right side the x terms cancel and it equals 55. Then in your second step, you're going to get your x alone. So get rid of the whatever's added or subtracted, get rid of the 19 by subtracting 19 from both sides of your equation. And on the left side the 19's are gone, you have a 9x, and on the right side you're going to have a 36. Alright, so to get your x alone, you're going to undo this multiplication by showing me that you're dividing both sides by 9. The 9's cancel on the left and you have x equaling a 4. For number, okay, so that's that problem. Now this one could be checked. You can check that by putting the x back into the original equation. So 7 times 4 plus 19, is that equal to negative 2 times 4 plus 55? So this is a 4 here. You should have a 28 plus 19 equaling a negative 8 plus 55. On this side you'd end up with a 47, and on this side you'd end up with a 47, so that is your check. So you should check all of these, and that's the process of checking. Number 2, you have a distributive property first. So the first thing I'm going to do is multiply the 5 to the x and then also the 5 to the negative 3. So on the left side you're going to have a 5x minus 15 minus 9x, and on the right side take the negative 2 times x, giving you negative 2x, also negative 2 times 17, giving you a minus 34. Now on the left side, these are like terms, and I'm combining them on the same side. So you simply just take the 5x and the negative 9x, combine it, you get a negative 4x minus 15. That's on the left. On the right, you have a negative 2x minus 34. So I did not change the signs on these two. I simply combined them. Whatever signs they had, I combined them. But now when I want to move it over the equal sign, I do the opposite sign. Let me clean that up. So to move my 4x to the right side, I'm going to add 4x to both sides. And the x on the left is gone. You have a negative 15 equaling a 2x minus 34 on the right side. Okay, so x's now are in one spot. We brought it to the right side and it's in one location. Now our job is to get it alone. So to undo whatever is added or subtracted, we will add 34. And then when you combine your like terms, you end up with a 19 equaling a 2x. These 34's cancel. So to undo the multiplication of 2, you show me that you're dividing both sides by 2, and x equals 19 halves. Make sure it's reduced, or you could write that as 9.5, or you could write it as 9.5. Any one of those would work, and you should check that as well. We're going to go on to number 3, however. In number 3, this beware, you're distributing this fraction to each term inside of the quantity. But this 8k doesn't do anything, so bring it down, and you keep your 8k, but now do the distributing. You're taking a negative 1/2 times a positive 2k. When I distribute this, the half and the 2 cancel, and you'll have just a negative k. Now you're doing the negative 1/2 to the positive 14. Negative 1/2 times a 14 is going to give you a negative 7. How many halves inside of 14? Or I'm sorry, if you take 14 and divide it by 2, it's really the same as multiplying by a half. So 1/2 of 14 is 7, and it's going to be a negative because this negative is in front of your 1/2. Equals your 15 plus 6k. Alright, now on the left side, these are like terms. You can slip a 1 in here. So 8k minus a 1k is a 7k minus 7 equals 15 plus 6k. Alright, I'm going to subtract 6k from both sides, and it'll show up on my left side as a 1k minus 7 equals 15. The 6k's cancel. So to get k alone, I'm going to undo whatever's added or subtracted, so I'm going to add 7 to both sides. And on the left side, you can write this just as a k. It's the same thing as a 1k. 7's cancel, and you're going to get a 22. And that one you should check as well. Okay, moving down, number 4, we will distribute the 3 to the x and the 2, so you will have 3x plus 6 equals 3x plus 6. Now actually, by me saying it out loud, hopefully you caught that it's the same thing on each side. So the red flag should go up here. Something's fishy. Something's different. But let's go through the process. Let's pretend that we don't know what to do. Although if this were the same thing, hopefully you'd realize no matter what x you put in, it'll work on both sides. But let's go further. Let's say that we're going to get our x's on the same side by subtracting a 3x and subtracting a 3x. Notice that the 3x is gone from the left and you get a 6, and it's also gone from the right. Now, we have an equation 6 equals 6. It's a true equation. It is true, and what that means is that you have infinite solutions. And infinite solutions would mean that any x satisfies the equation. So any x is a solution. So no matter what I put in for this x, it's the same thing that goes in here. When you both multiply it by 3 and you add 6, you're going to get the same thing on each side. So the key thing is what you ended up with was a true equation. And that will get you an infinitely many solutions. We say that this is an identity. We call that equation an identity whenever you have an infinite number of solutions. It's equal to itself. Alright, in example 5, you have an x on each side, and if I subtract that x, it's going to drop from the left and you'll get a 2. It's going to drop from the right and you'll get a 4. But this time, they don't equal. So you may scratch your head and say, well, what's up with that? What that means is that there's going to be no solutions. 2 does not equal 4 no matter what. So we say no solution. So when something is not true, this is a false statement. When you end up with your variable dropping and what's left is a false statement, you have no solutions. Alright, so to revisit the infinite solutions and the no solution here, let's write that in red. Infinite solutions are going to end up when you have something equal to something else, and it's the same, I should say something else, something equal to itself. So we have the same thing equal, and that's going to be called an identity. And what you had for the example of above is that 6 equal to 6. It doesn't have to be 6 equal to 6. It could be 0 equals 0. It could be 19 equals 19. Anything equal to itself, it's the same thing. It would be called an identity, and you have infinitely number of solutions. The no solution is when you have something, but it is not equal to that other something. So these are not the same thing, and you'd have then no solution. It doesn't make any sense. So what you had up above was that 2 was not equal to 4. But you could have something like 5 is not equal to 8, negative 3 is not equal to 2. Anything that's not equal to the other side would mean that you have no solution. This is only true when the variables are gone, when the variables drop out. So if you subtract them and they're dropping out from both sides and this is what remains, this is how you would interpret it. Okay, so you have the lecture and you can look at the book, you can rewind this lecture, but your job is then to do start your section 3.4, and then you can ask questions on those problems also in class. Alright, good luck.